In this video, we're going to look at how to sketch some different polar curves. And I'm going to give you a strategy for doing this. It's a little bit different than what Springboard shows you. And hopefully it will make the Springboard activity a little bit easier. We're going to start out with 3 plus 3 cosine theta. And what we're going to do is think about this graph in its rectangular form down here on this axis. So let me rewrite the equation there. We're going to let the y-axis be like our r-axis and the x act as theta. And we're just going to sketch a graph of 3 plus 3 cosine theta down here, a graph we should be familiar with. We have a vertical shift of 3, which means that midline is going to go up 3 units. And then we have an amplitude of 3. So from the midline of 3, we're going to go up to 6. That's where our max points will be, and down to 0. So our minimums will be at 0. Now, as we graph these on the polar grid, we're going to think about them a quadrant at a time. And so I'm going to mark off those axis angles, pi over 2, pi, 3 pi over 2, and 2 pi. So in the Springboard, they help you create a table of values to get points to plot to create your polar grid. What we're going to do is just sketch a graph, which will be quicker than creating a table of values, and hopefully be able to use that graph to help us generate the polar graph. So since we're graphing cosine starts at the top of the cycle, which means when I get back to 2 pi, I should be back to the top. It's going to reach that low point in the middle and cross the midline halfway in between those. And so our cosine graph looks like this. So let's see if we can take this and create a polar graph. Remember that the x-axis here, those are our theta values. The y-axis is representing our r values. So this point right here, I have a theta of 0 and an r of 6. So I'm going to go ahead and plot that point up here. Theta is 0, r is 6, right here. And at pi over 2, we have a radius of 3. So theta is pi over 2, the radius is 3. Okay, and remember, we're going to look at this one quadrant at a time. So that's 0 to pi over 2. Now with those 2 points, it's kind of hard to know exactly what that graph is going to look like. I will tell you that polar graphs are very curvy. They're very rounded. So this is not going to be a straight line connecting these two. But it would kind of help if we had a third point here. And what I'm going to do is pick an angle in here that would give me a convenient value to work with. Since our equation is cosine, the convenient angle would be pi over 3 because the cosine of pi over 3 is 1/2. So I'm going to plug in pi over 3, which would be 3 plus 3 times 1/2. That's going to give us 4.5. So at an angle theta pi over 3, my radius is 4.5. It's going to be this point right here. And that really helps us out in getting a graph. Your graph is going to look something like that. And I'm going to use some color coding to help us out here. So quadrant 1, I'm going to make that green. If you've got some highlighters, colored pencils, or something, it might help out as we graph these. All right, so there's quadrant 1. Now notice what happened here. Down here, the radius was decreasing. And up here, as we went through the graph, we're getting closer and closer to the pole. The distance to the pole, that radius, is getting shorter and shorter. So what happens here between pi over 2 and pi is the radius continues to decrease. And we're going to end up, when my theta is pi, the radius is 0. So that means we're going to end up here at the pole after we get through quadrant 2. So let's get the convenient point. Again, it's going to be at the pi over 3 angle. 3 plus 3 times cosine of 2 pi over 3 would be 3 plus 3 times negative 1/2. And that's going to be 1.5. So at 2.3, our radius is 1.5. That's that point there. And so again, this curve is going to come around and just get closer and closer to the pole until it's actually at the pole. So quadrant 2 down here, notice my R gets closer and closer to 0 until it hits 0. Up here, my radius gets shorter and shorter until we're finally at the pole. Now here's where we're going to use the graph to really help us out. Notice quadrant 2 and quadrant 3. Quadrant 3 is just a reflection of quadrant 2. And so the same thing is going to happen up here on our polar grid. It's just going to be what's happening in quadrant 3 is going to be a reflection of what happened in quadrant 2. That convenient 1.5 point at the 2 pi over 3 angle, we're going to have that again at the 4 pi over 3 angle. So 1.5. We're going to end up at 3 pi over 2, 3, this point right here. And so the curve is going to look like this. I already made it purple down there. Color that purple right here. And then in our last quadrant, quadrant 4, which I'm making pink, notice that it's doing the same thing. It's a reflection of what's happened over here in quadrant 1. Same thing's going to happen up here in the polar graph. We're just going to reflect what's happening in quadrant 1. So that convenient point of 4.5 is going to be at the pi over 3 angle. And the graph is going to finish up like this. And so this approach to graphing, it's similar to creating a table of values. It's just that we're using a graph down here, which is much faster to draw, instead of generating that table of values. And I want to graph one more for you here. Let's look at R equal to 2 plus 4 sine theta. R equal to 2 plus 4 sine theta. And again, I'm going to start out by graphing down here using the XY as a theta R axis, getting that rectangular looking graph that we're used to. So in this case, our midline is being shifted up 2. And I have an amplitude, I'm going to go ahead and sketch that midline across, amplitude of 4, which means we're going to go as high as 6 and as low as -2. Again, I'm going to mark those axis angles, pi over 2, pi, 3 pi over 2, 2 pi. And in this case, we're graphing sine. Sine is going to start out in the middle of the cycle. It's going to reach its high point, back to the middle, low point, back to the middle. There's our sine graph. And we're going to use this to help us generate a polar graph. So let's start out here. Theta is 0 and the radius is 2. It's going to be this point right here. And then we have a theta of pi over 2 and a radius of 6. Pi over 2, radius of 6. So we have those 2 points. It would be nice if we had a third point in between. And in this case, since we're dealing with sine, the convenient theta is going to be pi over 6 because sine of pi over 6 is 1/2. So I'm going to plug that in. 2 plus 4 sine of pi over 6, which is going to be 2 plus 4 times 1/2, which is 4. So at pi over 6, will be at this point out here. And so my graph is going to look like this. And again, I'm going to use the colors to help us out here. So this part is quadrant 1. Now, if I look down here at quadrant 2, it's just a reflection of quadrant 1. So up on my polar graph, when I graph the angles in quadrant 2, it's just going to reflect what happened over in quadrant 1. This convenient point at pi over 6, or at 4 pi over 6, that's going to happen at 5 pi over 6 over here. And then at pi, we're going to be back at 2. And so my graph will look like this. Try to get it a little more symmetrical. There we go. Okay. So you notice this is starting out similar to the previous graph, except that we're centered on the y-axis instead of the x-axis. And that's because this is a sine function. Previously, we were working with cosine, centered on the x. But starting out, same kind of rounded look. But let's see what happens in quadrants 3 and 4, because this is going to get interesting. Between pi and 3 pi over 2, notice down here, my radii go negative. We've got negative radius here, quadrant 3 angles. So remember what happens in polar, if I'm graphing and my theta is in quadrant 3, but my radius is negative, that means that those points are going to end up graphing over here in quadrant 1. That's not true for all of the angles down here. We're starting out in the positive, so we're starting out in quadrant 3, but at some point we're going to transition to quadrant 1. So the point 2 pi, we've already got that plotted. I'm going to go ahead and plot this point. 3 pi over 2 is the theta, and the radius is negative 2. Here's my theta of 3 pi over 2. Radius of negative 2 is going to go up here. And then my convenient angle, 7 pi over 6. So 2 plus 4 times sine of 7 pi over 6 is 2 plus 4 times negative 1/2. That's going to give me 0. So that means that I'm going to go through the pole right here. So this is the angle 7 pi over 6. That's where my radius is 0. My graph is going to go through the pole. And then between 7 pi over 6 and 3 pi over 2, all of those radii are going to graph in quadrant 1. Even though the angles are in quadrant 3, the graph is going to look like this. I hit the pole, and then it's going to loop around to that point up there at 3 pi, or at negative 2, 3 pi over 2, right here. And so all of these are quadrant 3 angles, but you can see part of it graphed in quadrant 3, part of it's graphed in quadrant 1. Now quadrant 4 down here between 3 pi over 2 and 2 pi. Whoops, that's the same color I used before. Let's try this one. Notice this is just a reflection of quadrant 3. Same thing's going to happen up here. We're starting out negative. My angles are quadrant 4 angles. Whenever the radius is negative, it's going to graph in quadrant 2. And so this part of the graph is going to come around through the pole, and then it will graph in quadrant 4 and connect back to the point where we started at 2 pi or 2, 0. So a really important difference between these two graphs that we did. Notice this first graph, we just touched the pole that corresponded to this point right here, this one point where the graph touched the x-axis. But in this graph, we actually crossed the x-axis and went into a section here where our radii were negative. And that's what gave us this inner loop on our graph up here at the top. All these negative radii graphing in the opposite quadrants.